All right, welcome everyone. Let me see who we have on our list today. Okay, welcome everyone. I can see I can see Otto, Captain Michael, Monserrat, Naimeka, Presa Detayo, so Vara, Abimbola, Tawakat, this is India, Tuyaja, hope I will not murder your name. So Luwani, Dominion, Oyedare, Grace, Gracious, yeah, Deleke, welcome to the live coding session for stage D. Oh, sorry, stage E. Yeah, the last one. And today is day one. I remain good Rich Okoro, so I'll be the one handling you in this live coding session. And I trust you've met me right from stage C. Yeah, stage D. So I was the one that took you through the practicals. And here we are again in the last stage, and I'll still be the same person to walk you through the last stage. Okay, so actually this stage is going to be a bit different, meaning that for today, I don't have a slide. Yeah, so we're just going to go straight into the project, and also just to let us know, we are actually going to be looking at a single project for 4 days, but we are going to be taking it gradually, breaking it down step by step. And I also think it's also an opportunity for us to learn. I mean, it's one thing is us knowing how to code, another thing is us knowing how to code better, right? So through this project I'm going to be working on straight. It's actually an already done project, but I think I'll just have to revive it. Yeah, and then walk us through how it was done. And it also aligns with stage E um topic, which is time series and forecasting, right? So yeah, my point is this stage is going to be different. The live coding session for the next 4 days is going to be different, and we're going to be looking at just one project. So that's with like the normal wrangling and everything. Then wherever we stop, we continue in the next day. And yeah, in case you have any questions also, you can also ask. And also what I'm trying to say to you is it's also an opportunity for you to learn how to be an effective coder, right? Most people they just write code and fill it in their notebook, and maybe they're not familiar with some concepts that can make your work more clean and efficient, effective and orderly, professional, right? So those of the not like what I'm about to show you is it's the or all I put it all over all. It's just the minor and basic things that you can do to make your code clean and yeah, make your work also neat. So it's not just bringing data, splitting and straight up you are predicting data and you're submitting your presentation, right? It's also how you can see how it's done in a company based, right, settings, right? So your models can be in a different file, your functions in a different file, right? Your cleaning process in a different file, stuff like that to make your stuff orderly. So enough with the whole talking. Let me just share my screen. So we'll just go through it together and we'll take it gradually, one step after another. So I'm going to be sharing I'm going to be using, just so you know, I'm going to be using my VS Code, right? My workspace. So far, we're using Google Colab, and that was because we are looking at well, I say short projects, and also using inbuilt data sets, right? But for this particular stage, which I said we are going to be looking at one project, I'm going to work with in my own local workspace, VS Code, right? So let me just share. I'm going to be working in my own workspace. So yeah, we'll just go through the project step after step. Today we may likely just look at bringing in the data and how to understand it, and tomorrow we'll continue from there. Okay. Um, Can you see my VS Code?
Yes.
All right, cool. Let me close this. All right, so I'm going to just open the file I'm going to work with. Okay, this should be it. Cool. Okay, so it's just one of the projects. Okay, let me just tell you how the project came about. It's one of the Harmony capstone projects during my set, right? Back when I was doing my internship with Harmony, and I was the team lead for the project. So it was not just my work; it was I and 13 other people from different across different countries, right? As like the usual, right? So we brainstormed together to come up with this project. And it's not as if this project came out as maybe the first position or no. I think we came out third or fifth, if I'm not mistaken. But I think but we are the top five. I can't really place it. But yeah, the concept is not probably to show you what I did or maybe how we did it and stuff like that. I think it's just showing you how because for this project, I really made sure that everything was clean as much as possible and we tried to make everything standard, right? So it's all about the process, right? And less about the outcome. Yeah. Yeah, we also built an app to show it's actually currency exchange. And I don't think the app is still alive. And it was hosted on my teammates' repository. Okay, but that aside, so the project is about currency exchange. I don't think we were given the data set, were we? I can't really recall, but yeah, data set is available, and this was I think 2 years ago. So this is the whole brief and everything. So I'm just going to go through it. Please just try and follow. And like I said, it's just this project we are going to focus on, and I think there is a lot you are going to benefit from it, from especially for those that are just starting, right? How you can be more organized. So in finance and exchange rate is it's all currency exchange and that blah 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 blah. So our main focus here was to actually predict the closing price of an exchange. Maybe after it came up, it opens, it goes high, it goes low, and so on and so forth. Okay. So this is just a brief introduction. I'll just go through it. I don't think I'll be able to. I can read it also, but I don't think that's necessary. You all can read. But I'm just going to give you some time. Let me zoom in again. Some time to just go through the introduction. So we are just trying to predict the currency exchange and determine which factors such as government policies, interest rates can affect it. We have some definitions, the IMF, and so on and so on. So our problem statement exchange rate of multiple currencies using historical exchange rate data and external economic indicators to get the findings on how to control inflation and have a study on the development state by means of economic statistics of all countries by analyzing whether the government has introduced better monetary policies based on IMF rules and regulations. So our objective is to predict and forecast the closing exchange rate of any specific currencies. Here we perform a time series analysis and build an ARIMA profit and regression model. I don't think we didn't have time to do regression. I can recall that we only touched ARIMA and profit model. We didn't have time to do this one. So results will be compared by evaluating the metrics, then predicting and forecasting future values of euro or United States dollar with respect to other currency. So in addition, the objective we can provide with the currency exchange rate data sets include analyzing the trend and patterns in the currency exchange rate over time, evaluating the performance of different currencies and assessing their stability and risks. The data set we have is historical and includes 113 currencies in total. Exchange values in varied permutation. It can be used for various tasks like time series analysis and forecasting. There are approximately 1.40 million rows and 7 columns in the data set. It's actually large. The data has two main columns in particular, slug and currency. Okay. So slug is of the form. So it's just, let's say USDT. Some of us are into crypto here, if I'm not mistaken. So it's like saying USDT, Bitcoin Cash. So this is just the form of the slug the slug column, where ABC and PQR are standard active currency codes as of ISO 41. Should be like a code something. Then currency contains a currency code. That is the next column, which is the unit of the value in the tables. For example, if the slug column is JPY, this is Japanese Japanese yen with Indian rupee, and the currency is INR, it means that one Japanese yen is something. Please correct me if I'm wrong. Is equals to X Indian rupee. So when you see it in this form, it is one of these is approximately the rate, the currency of this other one, where X is in Indian rupee. Then the other columns are the regular OHLC, open, high, low, close, along with the dates. Okay. So again, it's just what you guys have done in your Premier projects and capstone projects, right? But then again, I'm showing you one of the many project that was done, and also the thought process and how it was done, right? So I'm sure you learn one or two from how this project was done. Okay, so yeah, this is our process flow, data is collection, processing. We visualize a lot, we decompose it, we look for stationary data. You know, it's not all model that can handle non-stationary and stationary time series. So if your series is not stationary, I think you have to use a profit model, right? But if it's stationary, then we use the ARIMA model for that. Then we actually check for this. We're going to see everything. We checked for if it's stationary or not. Then the model selection. So we have the ARIMA and the profit model. So determine the order of difference D needed to make the time series stationary. Determine the order of auto regression P and moving average Q parameter required to model the time series. Why Prophet prefer the time series data into a data frame with two columns DS and Y. The DS column should contain the dates and the Y column should contain the dependent variable. That's the target. Then we create the Prophet model. So it is from here. If it is stationary, it goes here. I think I may have misplaced it. If it is stationary, it goes to this Prophet. If it is not stationary, it goes to Arima. I think we'll find out later on so that I don't end up confusing you. So once it goes into there, we do the fine tuning and everything. So it fits the Arima model, use the order of differences. That's it. When it is in this process, it does some selection for us. The difference, the auto regression, the moving average, that's the PDQ. It gets those value. Those value are now then what we use to do the final prediction. So we fit the Riemann model, use the order of differences, the regression, the moving average, we fit the Riemann model with the stationary time series. Then check the residuals of the Riemann model for randomness and normality. Then we forecast. We use the fitted Riemann to forecast the future values of the time series. Then while on this other side, if it is not stationary, we go to Prophet, we create an instance of the Prophet class and fit it to data. We make predictions and we plot the results. Then we evaluate and then we deploy the model. So it's just literally an overview of what we did for this project. Okay, so please follow me. Like I said, we're not going to finish everything. It's what we are going to work through for the next 4 days. So just follow me. Now, we import models. MFN function is a module that was created that contains the backend codes for all the functions used in this project, right? Or for the data set. So here we are not going to, you are not seeing, I mean, you are expecting to see probably scikit-learn or profits or matplotlib, pandas and the rest of them. But yeah, it's not here. So this notebook is actually cleaned, right? So I no let me use the word I we created a function, a module rather, called main function, right? So inside this main function module contains all the pre-processing and wrangling and everything in terms of coding that we need to do on the data set. So we are going to go there and I'll show you what it looks like. But yeah, we imported that function as MFN. There we brought in our plotly. I mean, there was no time. The plan was not to allow any importation to be done here. It was just to move everything to that file. But here, our plotly is here. We actually use plotly for our visualization. Plotly is an interactive library used for visualization. Right? Most of us are familiar with it. Personally, I like using plotly compared to other ones. Not like anyone is better than the other one, right? But I prefer using plotly and I've just gotten used to it. So I came up with the suggestion that we should use plotly. So yes, plotly is the library we used for the whole of this project. So let me run this. So I'm going to break everything down. So we are here to learn. Like I said, we're not going to rush this one. We just gradually connecting to my notebook. Can you guys still hear me? Hope I'm not talking to myself.
Yes, we can.
Oh,
Yeah, we can hear you.
okay. I think I need to. No. I just clone this from the referral. Okay. All right. So while that is installing on the back end, I'm just going to break it down. All right. So we need that, but I'm still going to run this again. Let me see if this is working fine. It's not going to work fine. Okay. So let's just wait for it. Sorry about that. Okay. So while it's installing, let me show you what the main function looks like. It's actually a module, a script that contains most of the functions we needed for the project. So the plan was actually to make our work neat and clean, in as much as probably Hamui may not even have the time to go through this stuff, but this is just how it's done out there in a professional setting, right? You don't just do things anyhow. You try to make your work organized and easy for someone to understand maybe your thought process and readability. Okay. So yeah, let me just close this. All right, so after importing our this is main function on the right hand side. It contains a lot. Don't worry, we're going to go through all of it, but it contains a lot of stuff with some comments about how to use the functions. But this is the back. I call it the back end of our project. Everything is being done through this module, but we'll come to that very soon. So here is where we import the function, these main functions as MFN. Right. Then we brought in our library plotly. This init notebook mode is actually you need it, especially when you're working with plotly. I don't know if you've noticed, or maybe someone has ever used plotly, and when you sent it to GitHub, you are not going to see the visualization. You can't see it if you are viewing your notebook on GitHub. That's because it's plotly, and it needs a kind of rendering in order for you to see a plotly chart on GitHub, but that process is usually going to take time. So we we introduce this. This is what you introduce so that when you use notebook viewer, if you use notebook viewer, let me see if I can quickly go there. Or probably we are going to see it eventually, but when you use Jupyter Notebook Viewer, I don't know if you're familiar with it, but I'm still going to show you. You can actually see the visualization online. So that's why this guy is here. Blah 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 blah. Okay. Now, mfn.data preview. Data preview is a function inside that our module that is just going to show you a preview of the data we are working with. So now let's go to the function and see how it was created, and then I'll explain what the just go through the data set again with you guys. So here is the first function. This is all what the usual stuff you would see in a normal data science project, right? The models you're working with, the stat models, the libraries, the cycling and everything, all what you need, right? So the difference here is you are not seeing it on the main notebook. You are seeing it as a module. And this is also to expose to some of us that are probably not aware. This is how the models you keep on importing are created. This is how it's done, right? This is how it's done. So this script, Python script is actually a module as it stands, right? So this is actually where we're reading our data set. Our data set is a Forex data set. Let me just open a preview of it. It's large, so it's going to probably take. Cannot open it. Hold on. No, I can't see open the preview. Okay, hold on. Let me read what is there. File above 50 MB cannot be synchronized. Okay. The file is actually large. Okay, let me try opening it with the data wrangler. Let me see. Okay, so while we wait for it to open in a tabular form, so we can see that with our pandas, this is what the data set looks like for different dates on a daily basis. Let me see if this one is okay. Yeah, sorry, I think I need to close some things. Please pardon me. Let me just close some things. Let me zoom out a bit. All right, so this is the data set we are working with, forex.csv. This is the slug column we talked about, right? It has no missing value, right? Then this is the dates column. It also has no missing values, right? Then this is all, for each exchange is on a daily basis. It opens on a particular at a particular rate, right? So in other words, this pounds slash this is Egyptian pounds and British pounds as of 2001, 10th of 6 April. It's opened that day with I think it should be five. Sorry, one British pound equals to 5 Egyptian pound. That was the explanation I explained here. Because I'm just trying to make sure we are following along so that no one gets lost. That was the explanation we are explaining here. That if you have a slot with this slash this, it means that one of Japanese yen is equals to whatever price you have in the rupee side. Sorry, in our data set for rupee. So in other words, it means that this guy now, this particular line, it means that 1 British pound is equals to 5 Egyptian pounds. And it opened with this amount as of this date, right? Then for that whole day, it went as high as this 5.5 and just a difference of 0.01. Then the lowest it actually went is just the same amount, the same value rather. Then that day it closed at this price, right? So yeah, this is the currency Egyptian pounds, right? So this is just the contents of the data sets we have. So we should also know that this data set is limited in a way because sometimes there are other factors that can influence currency exchange, right? External factors, hazard, and the rest of them. So those are the things we actually noted down in things we can actually do to improve our model. Okay, so now that we've seen what the content looks like, here was where we did a data preview. So I'm trying to say that this data preview was a function here. This is a function. Let me close this panel. This is a function that when you call on it, it just returns our data set. That's after you must have read it, dot head. That's why here it's just showing us the first 5 rows of the information we want to see. Okay, so this is the data preview. So the next thing we did was to separate this this currency into different columns. So that was what we call on the function slug split. So slug split equals to MFN slug split. It's going to do the splitting, and then this is like a whole new data frame entirely with the splitting. This is the first 5 rows. So what slug split does is it separates the left and right currency to a new column respectively, right? So it takes this global data, right? What it's saying is it's trying to work with, whenever you're working with the function, everything is just narrowed down within that function. It's local, meaning that had it been we do not do this global data, it's going to think this data is defined under this function. So this global is actually what is going to make this function understand that we are working with an external data, a variable outside this function. That's what this global means, in case you are not aware. So we are saying the global data, which is this our data frame, pick it up, right? So for column A, right, currency A, it's going to extract the first currency after splitting it by the slash. I mean, I could do this manually for you to see. So what I can do is I can do something like, give me a sec. Hold on, did I run this? I think I did. So I'm just going to do something like, let me say data is equals to this. Okay, so data is now holding just 5 rows of information. So what this, I just want to break this down in case you are confused. What this is going to do is, okay, it's doing something like data. It's going to pick up the slug, sorry, the slug column. I'm just going to do it for one. So I'll just do something like 0. So it's this something like dot splits. The default is always a comma, but we want to split by a forward slash because that's what you use to demarcate the both of them. And you have something like this. So for column A, this one, we are picking. Is there any question? Okay, it looks like we have a crypto person in our midst, Captain Michael. Okay, all right. So yeah, for column A, it's going to pick out the first one from the list, which is index 0, right? It's going to assign that to column. So that's just what is going on here, right? So data A is equals to string. It strings up for all the currencies in data slug and pick out the first one. Then column B, which is this one, right? It's going to pick out the index 1. So that was how we split the currency into 2 different columns so that we have it separated, even though we have currency already that represents the right hand side of that slug. But yeah, this is what this code is doing. I'm going to take this out. Okay, so after splitting this, what did we do? Check the possibility for currency A and currency B. Okay. We actually had 7 unique currency. We had 7 unique currency. Okay, so what this means is for Egyptian pound, for instance, how many are there compared to um other exchanges? Okay, please, I just want you guys to follow my thought process. Now, look at this column slug, right? Let me shift this a bit to come back to this. These are exchanges, right? So because we have Egyptian pound to Egyptian, doesn't necessarily mean that in this our data set we have probably um Egyptian pound to, let's say, Indian rupee. No, we don't. I don't know if you understand what I mean. So here we have British pound compared to Egyptian pound. So I'm saying because we have Egyptian pound here and at some point we have Indian rupee, we have Indian rupee. It doesn't mean that because there is Egyptian pound that there is also Egyptian pound compared to other currencies. No, it's not like that. So there are actually just unique currencies that are used for comparison. Like let me give for instance, right now everybody if you want to maybe don't know how to explain it, maybe you want to do something and be on a default site. You probably want to work with USDT, sorry, US dollars because it's kind of a universal conversion currency used for exchange, right? So you always want to maybe let's say you want to work for a Kenyan company that paying you in dollars. You want to work in Indian company that paying you sometimes in dollars. You want to work for some kind of country that paying you in dollars. So dollars is like a default currency they use, right? So having said that, in this our data set, we have just 7 of them that are used for comparison. So we have the British pound, you have the euro, we have the Australian dollars, we have the Japanese yen. I don't know this one. We have the USD dollars and we have the Indian rupee. So these are the unique currency that are now then being compared with other ones here, right? Thank you. That's the base currency. And that's what I'm looking for. That's the base currency. So these are the base currency we have in this our data set, and there are just 7 of them. So every other currency is being compared to this base currency. Okay. So that's what we meant by saying checking the possibilities for currency A and currency B. So we have 7 unique ones. Then on the left hand side, sorry, on the right hand side, sorry. Yeah, we have 7 on the left hand side. Then we have 113 unique possible currencies on the right, which vary according to the selected currency A. So what it means is if I select Egyptian pounds, for instance, British pounds, there's a possibility that you will not see Egyptian pounds compared to maybe any of these other ones, right? So that's why it depends on the currency A that you select. So whenever you see currency A in this project, it means the left hand currency. Whenever you see currency B, it means the right hand currency. So we created a function that does this for us. You see how clean this code is. Let's just see how it would have been if we were to bring in the whole function itself. So this is actually what is doing that. It displays the unique currencies on the left and right after splitting. So after splitting using this other function, this function is embedded inside here. You know what this one is doing. It splits it into A and B. It picks out currency A. This is this column. It returns the unique value. So that's how we got this 7. Are the base currency. Then it picks out currency B, which is this column. After it must have split it, right? It returns the unique values, and that was how we got to this 113. So if you count this, or you can probably do length of currency B. So let me run this so that did I run this? I did not. Yeah. Okay. So let me run this. So just in case you want to be counting manually, there's a shortcut you should know by now. You can use the length function on your currency B. So to return that 113, right? So yes, that was how we arrived here with the whole text part of it. This is where we added the text part, not literally in the function, right? But we all know that we can include this in the function and make everything automated, right? So yeah, this is what is happening. This is just what's more details about our data sets. So the next thing we did was
Okay,
data
sorry.
visualization.
Before you can
Any
continue,
question?
can yes,
Okay.
there is. Yeah. Okay. I've seen that you have used the slug split function to split the unique currencies that are there. So
Okay.
now, the first question, I have two questions actually. The first question is, why are we splitting all these currencies? Because they are in pairs, meaning that we are having conversions, right? And then
Okay.
why, the first question is, why are we splitting them? And then the second one is, when we would have a reverse conversion, right? What will happen then? Will we have a unique currency on the left hand side of the conversion, and a unique currency on the right hand side of the equation? Meaning that, okay, if we are comparing uh, Egyptian pound and a British pound, right? Let's
Okay.
say on the left hand side we're having the British pound, and then on the right hand side we're having the uh, Egyptian pound. And then now,
Okay.
after that, we inverse the relationship, meaning that now on the left hand side we're going to have the Egyptian side, and on the right hand side we are going to have the British pound. So, uh, how will that interfere with the unique currencies on the left hand side and then on the right hand side?
Okay. Yeah. I think I understand both your questions. Okay, so for the first one, we're actually splitting it for several reasons. One is for the visualization part, which you're going to see in a bit. Then secondly, it's also for the model part because most of these exchanges they are not stationary. Some are stationary, right? And if when we split it, we are able to focus on each section of the unique currencies. Like we can focus on Egyptian pound, we can focus on these seven base currencies. So us splitting it will help us determine. I think first of all, it was actually to let us know how many unique currencies are on the right hand side. This is just the first thing we're able to achieve by splitting it. Then the second one will be the visualization part, which we are going to see. Then the third one will be the model part when we are trying to predict. So we can easily see because obviously all of them will not be carrying the same there are different currencies, right? So it's not going to probably make sense if you are maybe dealing with them the same way you're dealing with other ones, right? It just like in terms of what's it called? Cryptocurrencies, right? We have stationary currencies like USDT, which other one do we even have? Self BNB and the rest of them. They are stationary. While we have the other ones that are going high and low on a daily basis. So you want to handle those stuffs differently. Then for your second question, I think yeah, you're saying what if it changed position? Maybe the British pound is now on the left hand side and the other is now on the right hand side. Well, that is, yeah, it's a very nice question, but then again, we don't want to be working with too much complexity, right? Right now, what this data set is all about, it's just showing you one of these seven base country compared to other currencies. So one of Egyptian pound is five Indian rupee, one of euro is 10 this, one of this. So these are base currencies, and it's just meant to be on the left hand side, right? But if you probably want to exchange it, it's you're doing a whole different conversion, and you need to handle that one differently, right? You don't want to end up having a mixture of maybe the base currency is now on the right hand side. So why, like in some cases, the base currency is on the right hand side. Some cases, the other currency is on the left hand side. No, you want to make your stuff uniform and you need to have a pattern. So if you want to take it to the other side, it's just a whole change of procedure, right? Just make sure that all of them are just having that same pattern so that you don't end up mixing up things, right? Because, for instance, if maybe at this particular column you're having Egyptian pounds just as it is now, then on this other side you are seeing Egyptian pound to this. You will need to put into consideration that at this point now it is one of this is equals to this, while at this part it is one of this equals to this. So all those stuff are things that you also need to consider if you are changing the position. Do you understand?
Okay, yes, I actually get what you're saying. So basically, in this case, we want an increasing ratio, meaning that the British pound in this case is higher than the Egyptian pound, hence the prices that are there. And so, yeah, if that is the case, then yeah, I suppose I understand you to keep the same conversion between all the currencies that we are having.
Yes. The conversion just needs to be, it just needs to be uniform and what's the word for it? It just needs to be uniform and everything should have a pattern. Yeah.
All right, thank you.
Okay. All right, you're welcome. Any other question from anyone? Okay. All right. So yeah, we've seen the function that is doing that already. So we just had to, all we are doing is just importing the functions and then calling on the function to do the work for us. This is just going to help our notebook being cleaned and the whole other processing stuff is on this other end. Then we have the visualization part. So inside Plotly, we have the there's this they have the OHLC kind of visualization that helps in terms of currencies that it's just built for currencies, right? It's used to help you show your currencies in the way that you like candlesticks. Yeah, that's the word I'm looking for. It helps you show your prediction in the candlestick, high, low, and the rest of them. Yeah. So this is just what the whole OHLC is used for, right? Okay, so I'm just going to explain how this function was created and why it is showing you the way it is showing you. So what we are seeing here, if you hover on each of these candlestick, you will see the open position. So the open position is actually this small. I think I need to zoom in again. I think we also had a visualization notebook just built for visualization only. I think we'll come to that. So we actually had like an exploratory notebook just meant for visualization. So let me just go back so that we don't lose track. Okay, so let me explain this chart quickly. I think I need to zoom in on just one of these. So let me zoom in on, hold on. Let me zoom in on this. So this is also what you can do with Plotly. Okay, now, yeah, for this one now, it means it's opened at when the day started as of April 14th, 2008. This is Egyptian pounds to, sorry, British pounds to Egyptian pounds candlestick. It opened at 10.723. And that's approximately this price. That's why you're having this guy entering inside. Then for that whole day, it went up and down, up and down, up and down. But the highest it went to, that's why you're seeing the highest 10.767. That was the highest it went to for that day, right? Then the lowest it went to is actually 10.644. Just so we know, this is coming from the data set, so I wish I could just show you that right now. Let me see. April. Okay. Let me see if I can quickly shift that out for us to see. Splits, slot split, column A. Oh, what is wrong with my this thing? GDP. It's much. I was thinking I'll be able to narrow. Okay, I think I can narrow it down to the date, April 14th, 2008. April 14th, 2008. So let me change it to date. April 14th, 2008. So that will be 2008 0418. So this is the whole information for Egyptian pound. We're looking for Egyptian pound. I think I've seen what we want. 723,767. I can't find it. Okay, so I'm not going to waste time because I'm already out of time. But my point is, all those informations are coming out for me, and I'm going to show you very soon in the function. So yeah, the low is actually this is the lowest it went to as of that day, 10.644. Then at the end of the day, it closed at 10.677. That is this one that is going out. Now, it is actually red because it closed at a price that was lower than when it came in. Why this one is green? Because it came in at it opened at 10.624 and it closed at 10.637, which is higher than the opening price. That is why it's green. So that's the color code. It's red because it closed at a price lower than the closing price is lower than the opening price. So at the end of the day, it's reduced. While it's green because the closing price was higher than the opening price. So yeah, that is just what this whole chart is, and we can see the trend from 2005 down to 2020. So this function can help you predict the first three exchange rates, or we can change it to two, or you can change it to one. So it's just going to it's that number determines how many it plots for you. So if I put one, it's just going to visualize just one of the exchange rates we have. So we're out of time already. So I'm just yeah, it's just one. So let me just quickly run us through how this function was created. Right. So this is the function. You can see how busy it is. I don't want to say much how busy the function. This is what would have been in this code, and obviously to make our work look somehow, in as much as we are on the right track and we are doing the right thing, but it will make our notebook long and filled with a lot of codes. And in terms of presentation, trust me, the management are not always after this. They want to see the end results, and that's the reality, right? Most people, not like they just don't have that time for you to, so I did this, I plugged the, no, 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 no. They're after the end result. That's just how the company setting is. But this is a function that is doing that. So it's going to pick out, depending on whichever currency I put in here, that's the one it's going to work with. So I can change this to whatever base I want. Out of those seven base, I can change it to whichever one. So it takes in a currency, which is currency A, and A are the seven base currency, right? Once it takes it in, it turns into a string. Then it filters our data frame, right? The original data set. Yeah. It splits it, filters the column A. It filters this column. I'm walking us through the function. It filters this column for whatever currency you passed in, just like I did initially here before I changed it to a date. It does this. This is what it does. It filters this out. Then what it does is, after that, it sets the index using the date. It sets the date as the index. Then what does it does? The slug, this one, it returns the unique slug. So what it does something like this. I mean, it's 8,000, 380,610 rows. But to know the distinct slug, you can do something like this. So yeah, it gets the unique slug. So I think there are about, let me see, there are about 94. So just for each British pound, my time is up. There are 94 unique exchanges with British pound, right? So that's what this guy is doing here. It gets this unique, it turns it into a list. So to list is just going to turn this, he's going to take out this array and turn it to a list. So this is what it does. Yeah, this is what it does. Then what it now then do is okay, equals to x for x in exchange. So for each of these exchanges, returns it, it filters it actually. It filters it, right? Now, if this OHLC is true, it's going to go ahead and, okay, I think I just need to practicalize this. My time is already up. So if I turn this to false, it's just going to return the data frame. Or let me just say, because the default is, sorry, what am I doing? Just hold on, let me confirm. The default is false, so it means I can just take it out. So let's say this was not included, or you have something like this. It's just going to return a data frame. It's just going to return a data frame. Okay. But if you set that OHLC to true, what it's going to do is it's going to go ahead and do a visualization using Plotly OHLC library, right? So it accepts the open, it accepts a high, it accepts a low. So all these are coming from the data frame, right? Then the legend is actually that price that we saw initially. Then it visualizes it. This stuff can be true. This range is actually going to bring out something that you can use to fit it in. Let me show you. But if I change this, I'll have to restart my panel because of the change. But I think I'll still show you that eventually. Um, it's going to bring out a slider. It's not yet. So no, I'll show us that in the next class. It's actually going to bring out a slider that we can use to slide our. Let me look for the our raw code base. Oh, our raw code base should have that. Okay, I won't have time to go through that now. So I'll just do that in our next class. So let me just allow us. Do we have any question for me? In our next class, we'll just continue the process and we have a lot to learn. The whole stuff, processing, down sampling. So like I said, it's a whole big project. Yeah, this is the slide that I'm trying to even bring in. This is what I'm trying to bring in. So we're going to go through all this, then the whole visualization, then the like model start coming in and yeah, we'll see how it works and the rest of them. So does anyone have any question for me? This is where we're going to stop for today. Any question, anything you want to ask?
Okay, yeah. I actually have a request on what we're dealing with
So,
at the moment. Yeah. So,
okay.
uh, the request is, can you please, when you are sharing your code, also share the modules that were imported, just like the main function that you are working on, which you are importing on the code that you are using at the current moment. Because for some of us, it will be good to follow from the back end, like you said, and then understand what that
Okay,
particular module is doing.
okay. No, I'll do that in our next class. So you mean me just explaining what all these options? I'm hearing myself. Do you mean me explaining all these models, what they are doing? Is that what you mean?
What? I didn't get that. What?
Are you saying that I should have, you want me to explain what all these models are doing? Is that what you're asking? Or how I, like how the whole import main function works? Is that, which one are you asking? Is it explaining this importation or how this import main function works?
No, what I'm asking is to share also this module that you created, which I see that you created, right? Just so that you can make uh, the uploading much easier, and then the preview of the data that you're uploading much easier when you are actually working on the data, so that you don't take time to clean the data and then work on the data before you can apply the models that you have. So what I'm asking is to also upload the main function.py file when you'll be uploading the code that we are having here. I don't know if you understand what I'm saying.
Uh, when you say uploading it to where? Okay, see, let's continue in our next class, but I'm not sure I understand your question. I'm already taking other people's time. So let's
Okay.
just continue in our next class. Yeah.